In 1969, a paper appeared in Compte Rendu of the French Academy, a paper by Chevrel, Sergent, and Prigent, announcing that they had found a series of new compounds with the chemical formula something like PbMO6S7. They were reported to be trigonal by X-ray powder diffraction. The rest is done at Bell Labs. Bernd Matthias found this publication. They made it in a very crude way. They went to the AC susceptibility and they found the superconductivity. So the superconductivity was discovered in Bell Labs, I would say, by Bernd Matthias. Then he came to me and he said, "Would you please tell me what is the structure of these compounds?" I determined the structure and the formula at the same time. And the formula was indeed PbMO6S8. They did a very good job, but not on the original Chevrel phases. No. I mean, this is literature. This was discovered by Horst and Fischer, that the critical magnetic field of PbMO6S8 was the highest ever. Compounds were brittle, and they needed a lot of processing studies in order to be used as wires.
You can use ex situ or in situ method, like MGB2. You take precursor powders like MOS2, PBS and molybdenum powder, and you mix it, you put it into the wire, and then you draw the wire, and then you do the chemical reaction in the wire. And in this case, of course, the control is not so good, because many things may happen during wire drawing.
For the precursor, we invented a method applying hot isostatic pressing, and the result was a block like this, fully densified, which contains about 50 to 60% already reacted Chevrel phase, and the rest ingot of the precursor. And from this block we usually cut rods and fill them into tubes and make the wires.
There is a good relationship between powder technology and the fabrication of superconductors, which was initiated by Künstler at Bell Labs in the 50s. This technology has been then applied for Chevrel phase wires.
The Chevrel phases were put in a shadow by the discovery of the ITCs, because they had the same problem of granularity.
A typical example for the behavior of a granular system. Here we have a measurement of the AC susceptibility, which is a function of temperature. You can see here a first transition, and here you can see a second transition.